already discussed about this thing in the very first 1 or 2 classes of this AI course. Natural language. What is the meaning of natural language? Language in which human speaks. Very good. so the language by which the human beings are communicating with each other, right? That is called natural language. Now, so now let's start. Now, so far, whatever we have discussed in this AI course, if you carefully observe, we are actually confined ourselves to discuss what happens inside a particular agent, right? How an agent perceive, how an agent learn, how an agent involves in searching, etc., etc., right? Now the time came when we want to discuss that if there are a group of agents present, then how, and if they communicate with each other, then what are the issues that will come, right? And it is exactly the same thing that could be happened when a group of human beings, the group of people communicating with each other, right? So if you have an idea that when 2 or 3 people join and start communicating, then what are the possible issues, right? The same kind of issues will be applicable when a group of agents will start communicating with each other, right? So that is actually the goal in natural language processing, right? Because so we assume that the agents will communicate through some language, and that must be the natural language, right? Maybe and one thing is that if the language that they will choose, that is the exactly the same language that all of them will be comfortable, right? For the human being also, it is quite obvious that if I don't understand, say, Hindi, and 2 of my uh, companion will start communicating in Hindi, then I can't understand that, right? So that's why the language that they will choose, that is obviously should be familiar by all of the people present in that communication, right? So you can get a lot of bookish definitions of communication. So I am just picking one of them. Now let's see what is written over there. Although it is very much complicated, communication is the intentional exchange of information brought about by the production and perception of signs drawn from a shared system of conventional signs. Now just try to understand every segment of that. So first one is intentional exchange of information. So obviously, if someone says something, so when a speaker says something, means that person is a speaker at that instant. So the speaker should have something to say, right? So that have the intention. So that's why it is an intentional exchange of information. And from a shared system of conventional signs. What is the meaning of that? The shared system that I have just told you, that every person or every type of animals has their own conventional signs of communicating, right? So like the example that is given over here, the leopard alarm is a conventional signs that both alerts others that there is a danger in the bush nearby. Similarly, a short calf for eagles, chatter for snakes. So these are the conventional signs of communicating of different animals. Similarly, human being has also some conventional signs of communicating. So that is the thing, that when some people or some agents communicate with each other, they should choose a shared system of conventional signs, right? And if that sign does not understand by the other, then there is not a communication is taking place. Fine. So most animals employ a fixed set of signs to represent messages that are important to their survival. That is very much obvious. Fine. So what is for the human beings? So that is that conventional sign is said to be the language, right? And that's why the name came, that the natural language. So language actually is a structured complex system of signs known as language, and human beings are used that thing, and that is called the language, right? It may be English, it may be Hindi, it may be German, it may be Spanish, it may be French, anything. Okay, so every language has its complex structured system of signs, and with every language there is an underlying grammar, obviously, because without the grammar, because grammar, what the grammar says the syntax, grammar says that the rules. Okay, now since you are studying formal language and automata theory in this semester, so you should have an idea that the how grammar can be written, how the language can be constructed from the grammar. So you have a clear idea. So the same thing will be happen for the natural language also. There will be the grammar. From the grammar, the sentences will be formed. Okay. Now, one of the actions that is available to an agent is to produce language, either by talking or by writing or by using sign language or by anything else. So when an agent is communicating with each other, it produces the language, and how the language will be produced is produced by saying the words, right? Because the basic unit is the letters. From the letters, the words will be formed. From the words, the sentence will be formed. Okay. Now, that communication can be either by talking, it can be either by writing also, it can be using some other sign language, and that sign language also should be shared by the other people present in that communication, right? Now, as far as this language is concerned, whenever we are talking about some music, music also has its own language, right? Because music has its own grammar also, right? I am very much sure that if some of you are very much involved in the music, so you understand that thing, right? The music has its own language. Because that is for music, there is the underlying structure. There are some notes. Okay, so that is actually the grammar of that music. Okay, so that is also a language. Okay, it conveys something, right? Fine. Okay, fine. Now, when I am talking about this music, I just remember one thing I should share with you. If some of you are have a working knowledge of machine learning and have a interest in music, for them, I can say that I have a project on this domain. So if anybody is interested, you can talk to me later. Okay. So one thing is that you should have a working knowledge of machine learning. So that means that there is you did not get much scope to learn and then apply, because not much time is there. So you should have a working knowledge of machine learning. And another one is that if there is a prerequisite is if you are interested in classical music. Okay, if you have a knowledge of classical music, then it will be helpful for this project. Okay, so that much I want to say at this moment. I can't say too much here. Okay, fine. So sorry. তোমার কথাটা ক্লিয়ার আসছে না দেবদি। হ্যাঁ বলো। Now, actually, why I am saying the working knowledge of machine learning, because মানে তুমি যদি একদমই কাজ না করে থাকো, তাহলে যেটা হবে যে you have to take much time, মানে তোমাকে প্রথমে মানে ব্যাপারটা হচ্ছে যে যখনই কোনো একটা প্রজেক্টে কাজ করবে ইউ হ্যাভ টু লার্ন সামথিং, রাইট? তো তার জন্য ইউ হ্যাভ টু স্পেন্ড সাম টাইম, ওকে? বাট আই এম নট শিওর যে কতটা টাইম পাওয়া যাবে এই প্রজেক্টটার জন্য। মেবি মানে হয়তো অ্যাটমোস্ট 6 months টাইমস ইউ ক্যান গেট, রাইট? তো এবারে 6 months-এ যদি তুমি পড়ে বুঝে করতে পারো দেন there is no problem, okay? Okay, so that's why I am saying that if someone has someone has worked at least some work on this, then it will be helpful. Otherwise, if you are interested, you can do, no problem. Okay.
স্যার এই পার্টটা কি আপনার মেশিন লার্নিং এর সঙ্গে রিলেটেড?
কোন পার্টটা?
মানে এই আপনি যেটা পড়াচ্ছেন ল্যাঙ্গুয়েজের এই পার্টগুলো।
আসছি আমি, সেটা তুমি বুঝতে পারবে। আমি একটু এগোই তাহলে তুমি বুঝতে পারবে, ঠিক আছে? Okay, fine. So now come to the fundamentals of language. Why I am saying this thing, because at this moment here we actually confined ourselves to English, right? Because English is we understand, everyone understands English, so that's why we are taking English as a natural language. Okay, here so you understand the difference between the formal language and natural language. Now since we are talking about the English, so some components, although you are very much familiar with that, the components of English language, but you should have a clear idea if you are working on a natural language processing, right? What is noun, what is pronoun, what is adjective, adverb, verb, then noun phrase, verb phrase, etc., etc. All those things should have a clear knowledge to you. Otherwise you will get a problem. Because you see why I am saying you will get a problem. Suppose, as I said, that the language, there is a grammar, so you have to write a grammar, right? And you know how to write a grammar. So suppose these are the variables, right? As far as your automata knowledge is concerned, you know that there are some in a grammar, there are some non-terminals, there are some terminals, right? So here this NP is for noun phrase, VP is for verb phrase, and S is a sentence, right? So these are the variables, right? Now suppose I have written a rule, grammar rule like this: S produces NP followed by VP. So what is the meaning? The meaning is, this is one of the formation of the sentence. There can be a variety of sentences, variety of other ways to form a sentence. This is a very short example of a small example of a sentence, that a noun phrase followed by a verb phrase, right? So these are the variables, right? You know that whenever grammar is written, it is written in terms of the variables, and at the time of parsing, these variables will be replaced by the terminals, right? So at the end, in the bottom part, at the leaf node of the parse tree, you will get a sentence, right? When you replace those variables by some terminals, right? So this is the example of writing the grammar here. Okay, now you can have an idea that it is very much difficult to write a grammar for a natural language. Why it is so? Because I hope you have seen that thing, that for a formal language it is rigidly defined. Okay, so formal language, writing a grammar for the formal language is relatively easy than writing a grammar for the natural language, because natural language is very much flexible. Okay, you can get the idea. English language is very much flexible. You can write a variety of sentences in an English language. Okay, so it is very much difficult to write a grammar for that. Okay, so that's why if I just discuss this thing first, and then I will go back to the previous slide. So that's why these are the different approaches of NLP works, right? The first one is the rule-based methods, that is by writing the grammar, right? That I have just mentioned in the previous one, that by writing the grammar, that is called the rule-based methods, and that is the most difficult way of approach of doing the NLP works, right? Next one is the using probabilistic modeling and machine learning. Okay, that Pranay has already just asked me the question that whether it is related to machine learning or not. Machine learning is an approach. Machine learning, see, this idea, I get so many questions from different students that I want to work with in machine learning. So see, machine learning is a tool. Okay, just try to understand the concept. Machine learning is a tool. It can be used in different applications. NLP is an application. Okay, you can apply machine learning tools to solve NLP problems. Okay, so machine learning could be used in variety of areas. Machine learning could be used in a biomedical field. Machine learning can be used in a mechanical field. Machine learning could be used in a civil field. In every field that you can apply machine learning. Machine learning is a tool. Okay, it consists of some tools. Like, say, we have already discussed about some of the techniques like decision tree, naive-Bayes classifier, artificial neural network, genetic algorithms. These are the machine learning tools. Okay, so by combining this probabilistic modeling and machine learning, there is another approach of NLP works. And the last one is using the deep learning. Okay, deep learning is another, is a higher part of machine learning. There are some tools like, say, RNN, CNN are there. These are the tools of deep learning, right? These are the models of deep learning. So deep learning also can be used for NLP work. So as I said, that nowadays, if you search in the internet recent works on NLP, you will find, if you search 100 works, you will find 90% of the works are done on these two approaches, second and third. Why it is so? As I said, that by taking this approach is a very difficult one, because you can get an idea that how much difficult to write a grammar for a language, right? So this approach will be very much difficult. If you can do it, that is very good work. If you can do it successfully, it is a very good work, but it is a very difficult one also, right? Are you getting? Any question up to this? RNN CNN হচ্ছে deep learning tools, হ্যাঁ, deep learning tools actually.
Sir, ANN টা কি machine learning tool?
হ্যাঁ
ANN টা কি machine learning tools?
ANN, হ্যাঁ, দেখো, deep learning or machine learning, but deep learning is a higher part of machine learning. আর ANN is obviously machine learning. Artificial neural network is a learning tool. এগুলো তো আমরা আগের দিন পড়েছি. So it's a learning tool. Learning মানেই তো it's a machine learning. Learning means what? Learning is a machine learning. Okay, fine. So now come to this slide. So this is the communication steps, right? So what is mentioned over here? So two parties are there. One is the speaker, that is denoted by S. There is another party, which is the listener or hearer, denoted by H, right? So what is written here, that the speaker wants to convey the proposition P to the hearer H using the words W. Okay, so now this process is composed of 7 such steps, where the first three is taking place in the speaker's part, and the remaining 4 is taking place in the listener's part. Okay, so let's see what is trying to say. The first one is, say, intention. Intention means what? S wants H to believe P. So it is very much obvious, because whenever we are saying something, we always want that the other party should believe my word, right? Otherwise there is no meaning of saying anything. Okay, that is the intention. Okay, maybe that listener cannot believe my word, but my intention was always so that the other party should believe. Okay, second one is the generation. Generation means that to convey the proposition P, S chooses the words W. W is coming from the vocabulary, okay, from the dictionary. So there is a vast dictionary for say English language, and whenever you are talking something, you should choose the words from that vocabulary. That is the meaning of generation. And synthesis means then after choosing it, S utters the words W, so addressing it. So these are the 3 steps that is taking place in the speaker's part. Now come to the listener's part. First one is perception. Perception means H perceives, listener perceives this W. Now that is a real world convention, but ideally, if the 2 parties are far apart, maybe H did not perceive exactly what the speaker says. Okay, it can be a misperception. It can be possible. Now, whatever H perceives, it will analyze it. Analysis means what? 2 type of analysis: syntactic analysis as well as semantic analysis. You know all these things. Parsing, you know parsing. Syntactic analysis means it's a parsing, right? Because after this parsing, then it comes to know that what it has perceived. Next thing is disambiguation. Disambiguation means what? Now see, natural language is very much ambiguous in nature. You know what is the meaning of ambiguity, right? Why natural language is very much ambiguous? Because natural language is context sensitive. Okay, so it may happen that for a word, 2 type of meanings are there, okay, in different context. So now that is the job of the listener, that is the job of the hearer, to find the exact meaning, the relevant meaning that the speaker wants to convey, okay, or intended to convey. And after this, the last one is the incorporation. H decides to believe P, right? So these are the 7 steps that will be taking place when a communication is involved. The communication starts between a speaker and a hearer. Okay? Now,
মানে স্যার এই ডিভিশনটা কি আপনি মানে নিজের মতো করেছেন না এটাই লজিক?
কোনটা?
মানে আপনি যে গ্রুপ মানে গ্রুপে ভাগ করে নিয়েছেন, এটা কি আপনি নিজের মতো করে করেছেন?
না নিজের মতো কেন, তুমি দেখো না, এখানে তুমি দেখলেই তো বুঝতে পারবে। মানে এই যে 7 স্টেপস এর মধ্যে প্রথম 3টে হচ্ছে স্পিকার পার্ট, কেননা হিয়ার দ্য মেন পারসন ইজ দ্য স্পিকার। Speaker,
আচ্ছা,
once speaker chooses, speaker utters, so that is the speaker's part. But at the last 7 steps, that is the hearer's part.
ওকে স্যার।
Okay, মানে এখানে আমার কোনো ব্যাপার নেই, এটা তো ইটস ভেরি ভেরি মাচ অবভিয়াস।
ওকে স্যার।
Okay, now come to the applications. Okay, there could be a number of applications of NLP. It is not very possible to show you all type of applications, although I'm just showing some of them. Like say first one is the machine translation. Machine translation means it's the translation from one natural language to another, right? You are very much familiar with this type of work nowadays, because Google Translator is the same thing that is doing. Okay, so you say something in your language, and if you want to translate it to some other language, it will do it. Okay, but it is not a one-day job. Okay, this work is a very long way. It starts, right? Say 1985, Spanum can translate a Spanish passage into English of its quality. Xerox made a system named Systran that translates their maintenance manuals into all languages that Xerox deals with. Right? So you can get an idea, because translation from one natural language to another language means your system should know the grammar of both the languages. Otherwise, it is not possible to create a meaningful sentence. Right? To create a meaningful sentence means the semantics comes into play. So meaningful sentence means you should know the language very well. You should know the language very well means you should know the grammar very well. Right? Second one is information retrieval. Information retrieval means it's actually whenever you are giving some queries to in the Google, Google will try to find out the relevant documents, relevant documents of your query, right? That is called the information retrieval. Okay, and not only it retrieves the document, it will sort it. It will sort it as far as the decreasing order of the relevance, right? Mane it will place the most relevant one first, and then gradually it will decrease it, right? So that is called the information retrieval. Next one is text categorization. Text categorization means that although it is very much easy for human being, that suppose different type of newses are there, maybe there are sports news, political news, page 3 news, national news, international news, etc., are there, and you want your system to categorize those newses, those texts properly, right? So that is the job of the text categorization. Next one that is given here, that is extracting data from text. What is the meaning? The meaning is, suppose a passage is written over here like this, okay, but by reading this passage, it is very difficult to understand clearly what is trying to say. Okay, so if it is possible that by reading this passage, you can create a structured template like this, then it will be very easier to get what is trying to say. Okay, so that is a system. Caesar is able to take the following Dow Jones news service story and generates this template to add to a database. So it is added in the database in this form, right? So that is called the extracting data from the text to create a structured data. Okay. Now, apart from that, there are some other works that is not mentioned over here. Although I have given one of my project groups in the last year one work that is the title generation from abstracts of research articles. Okay, I hope you can understand what I'm trying to say. A couple of abstracts of research methods. Text categorization এর third point টা বুঝলাম না, আচ্ছা আসছি আমি পরে. So suppose you are given the abstract, you know, মানে I hope many of you have already read some of the research papers. From the research papers, the first segment was the abstract, which actually gist the whole work, right? So these such abstracts are given to you, and from that abstracts your system will try to generate a meaningful title. That is called title generation. Okay, so that is one work of NLP, right? Because see, it is not that you just pick the significant words and place one after another. That is not the case, because if you do it, then it may not be a meaningful sentence. So to get a meaningful sentence, you have to do something else, right? Now, apart from that, there is the more popular familiar works, say sentiment analysis. You know, sentiment analysis means that a review, product review or movie review is given, and you have to find out that whether the review is a positive sentiment or negative sentiment or neutral. That is called the sentiment analysis, right? Okay, now Pranay says that Pranay could not understand the third point of the text categorization. What I am saying over here, they are also far faster and more consistent. So there has been a switch from humans to automated system. What is saying over here, that it is not very difficult job for the human beings, right? Human being can do it very, very fast, but your system should be much more faster and consistent compared to human beings. Then only it will be a good one, right? Because you will replace human being by this system, right?
So মানে human being এর থেকে faster হতে হবে, মানে
obviously যদি সেটা না হয় তাহলে how do you replace human beings by that?
Yes,
right? Okay, so up to this, any question? Because system shows me less than 1 minute time left, so I will start the next session immediately. But if anyone having any question, you think about that, and you can ask me in the next session. Okay, fine. So I am stopping over here, and you please join in the same link. Okay, fine. So now let's move on. So now I am moving to the text understanding system. So what is written here, that in real text understanding systems, the input is a sequence of characters from which the words must be extracted. Now there are 4 such steps: tokenization, morphological analysis, dictionary lookup, and error recovery. Now let's see what each of these steps say. So first one is the tokenization, is the very first step. Okay, whatever NLP works you will do, your first job will be the tokenization. Now what the tokenization says, tokenization is a process that splits an input sequence into so-called tokens. And what is the token? Token is a useful unit for semantic processing. It can be a word, a sentence, paragraph, etc. So basically, token is a basic unit. Okay. Now it is up to you whether you treat a word as a basic unit, or sentence as a basic unit, or paragraph as a basic unit, right? But for the convention is that for most of the works, we treat a word as a basic unit, right? Now here I am showing you one small example of Python to tokenize the text. Okay. Now this tokenization can be done in variety of ways. Here I am showing the example where the tokenization is done by the white space character, right? White space character means as soon as you find a white space character, whatever you will take or whatever you will get before that, that will be treated as a token. Okay. Now it can be done in variety of ways. It can be done using punctuation marks also, right? As soon as you find a punctuation mark, you will stop and take so far the text as a token. So now here it is a white space. So NLTK is a library. Okay, NLTK is a library that will be required to do any NLP job in Python. Okay, so you have to import NLTK. This is your text, suppose is a single line text. Now you do the tokenizer. So after this, you will get tokens like this. Okay, so this is Andrew's text is not it. Okay, so these are the tokens. Okay, so from that token, actually you will proceed. Okay, so your whole text will be divided or splitted into a number of such basic units. Now from those basic units, some of them you can discard. So that is up to you, that which one you will discard or which one you will keep it, etc., etc. That is up to you, right? So for the semantic processing, you do the processing with this set of tokens. Now after you got these tokens, you have some next works. Now what is the next works? The next works are some normalization. Normalization means what? Now same token can be used for different form of words, right? Maybe you have written in somewhere in your text wolf word, in somewhere you have written wolves. Now both of these you should understand, or your system should understand, that for both of these words the token will be wolf. Similarly for talk, say you have written talk in somewhere, you have written talks, you have written talked. Okay, for all the cases your token will be talk. Right. So for doing this, you have 2 type of normalization process. One is called the stemming, another one is called the lemmatization. Okay, so these 2 are different. Okay, in conceptually these 2 are different. How they are different? First one, Stemming means process of removing and replacing suffixes to get to the root form of the word, which is called stem. Like say, you have written the word caresses, right? So the rule says if you have SSES at the end of the word, you will discard this ES and take only SS. So caresses, your token will be, the root form will be cares. Similarly, if there is IES, you discard that ES and take only I. So if there is ponies, the word, you take pony. Similarly, if there is S, that means for the plural form, cats, your root form will be cat. If there is ing, you discard this ing, you take the root form, that is motor. So basically, you discard the suffix part to get to the root part. That is a stemming. But what is lemma? Lemma is, it returns the base or dictionary form of a word called lemma. So I am coming to that dictionary. What is the meaning of dictionary? But you just think that there is a dictionary. You know what is dictionary. And in the dictionary, there is the base form of every word, right? But in your text, maybe you can use a different form of that word, right? Maybe feet, right? You have written feet. So but feet will not be found in the dictionary. What is it will found? It will found foot. Similarly, wolves. You don't find wolves, right? Your base form is wolf, right? So I hope you get the idea, the difference between the lemma and stemming, lemmatization and stemming. Both are the normalization work, but they have the different meaning. Any doubt? Any question up to this? Okay. Now, as I have told you, mentioned about the dictionary in this case. So let me show you how a dictionary should look like. A dictionary should look like this. Okay. What it contains? It contains a vocabulary or lexicon. It is a lexicon or vocabulary, the same meaning, of a huge set of words. Now, to create a dictionary like this, that is not a matter of joke. It is actually a huge project to create a dictionary, because dictionary will help you to do the NLP job, right? You don't need to bother about the dictionary when nowadays you are working on NLP. Okay, you have a dictionary named as WordNet. It's a worldwide benchmark dictionary. Every researcher across the world who are working on NLP, they actually referred the dictionary WordNet. It's containing a roughly 1 lakh words, and not only words, a different forms of those words. Say, as for example, I am giving one example here. Say the word noun, the word right. It's a noun. It can be used as noun. It can be used as a verb also, and different meanings of the word. Right? Are you getting it? Okay. But it may happen that because it containing words, say 1 lakh words, and nowadays, due to this WhatsApp language, or maybe the other social media language, every day a new English words will be generated, right? It is very, very common that nowadays a different new type of English words, English language, and every day it is generating, right? Now, it may happen that in a text, if you use those kind of words, you may not find those words in the dictionary. Now, what will happen? Okay, and that is called the error recovery. Okay, so if you did not find that word, suppose smartply is a word that is used somewhere in the text, but you did not find it in the dictionary. So now in that case, from the structure of the word, you could get an idea that maybe it's an adverb, right? But suppose you have find a word which is written in capital letter in a text in between, in middle of the text, and if you don't find that word in a dictionary, you can get an idea or guess that it may be a proper noun. Okay, so in this way you can get recovered from those cases. Okay, so it is quite possible that you did not get any word in the dictionary. Then what will happen, that step you should think about beforehand, that if it is happened, then what I will do, right? Is it okay up to this? Okay, so if it is okay, now we move to the next part, next segment, that is the language models. Okay, what is the meaning of language models? What it does? Okay, so let's see. Now I am starting this with an example. What is written over here, that this is the, okay, this is a sentence. Suppose someone says these things, suppose it is a phonetic conversation. Okay, so phonetic conversation means there will be noise. Now if there is a noise, now suppose someone hears clearly up to this, but after that the word that is talked or that is mentioned, that is not clearly audible, right? It may happen. So now what will you do? So you have to guess that what is the next word. You have to predict. Suppose you have this set of possibilities. So what the language model will do, language model assigns a probability to each possible next word. Okay, and it will take the word which is probable to occur, likely to occur in the next. That is the job of the language models. Right? Are you getting? So what it will do, it will find the probability of the house as a next word, the probability of rat as a next word, probability of deed as the next word, probability of malt as the next word, and so on. Okay, and it will put that word after that, after the word the, which is the most probable. Okay, so there is a language models. Now as I said, that the application where you could use these language models, one of the applications is the speech recognition, right? Speech recognition in a noisy environment. So in a noisy environment, it may happen that you could not hear the word properly, clearly. So you have to predict, right? Similarly, spelling corrections. Suppose you have written that there are 2 midterms, right? So is it when after this word there, whether R can be placed? Okay, that is the question. Okay, so for that you have to, so for spelling correction also you can use this language model, because you have to say that this air, so that is a spelling mistake, that this air should be replaced by this is a there, this there. Okay, because it's a mistyped. Similarly, for machine translation also there is a role of the language model, right? So language model, so after tokenization, language model also plays a very important role. Okay, and the model that we very frequently used over here, that is called the n-grams model. Okay, now what is n-gram? N-gram is a sequence of n words. Is a sequence of n words. Now if it is a 2 gram, that means it's a sequence of 2 words, like please turn your homework. So always the sequence of 2 words. If there is a sequence of 3 words, then it is called 3 gram or trigram, right? So what has happened, since you already studied or we have discussed about naive Bayes classifier, so I hope you should not have any difficulty to understand this thing, right? It is almost same thing. The concept is same. It's a probability, because it is very much obvious that it's a probabilistic study, because you have to predict the next word. So you have to find out the probable word, right? So task is to compute the probability of W such that H. That means to compute the probability of a word W given some history H, right? Now the question is that how long the history will be. On that basis, you have to say that whether it is a bigram model or trigram model, or in this way the n-gram model, right? So just for example,
স্যার
here I am
বলছি
giving,
এক্সামটা একবার রিপিট করবেন প্লিজ, আমার একটু মধ্যখানে নেট চলে গেছিল।
হ্যাঁ বলো কি বলছো?
স্যার বলছি এন গ্রামটা একটু প্রথম থেকে রিপিট করবেন প্লিজ, আমার একটু নেটটা চলে গেছিল বলে ডিসকানেক্ট হয়ে গেছিল।
আচ্ছা, না n-gram কিছুই না, মানে জাস্ট n-gram is a sequence of n words, মানে আমি বেশি কিছু বলিনি এখনো অবধি, ঠিক আছে? n-gram is a sequence of n words, মানে if you put n as a 2, then it will be a 2 gram. If you put n is equal to 3, then it will be a 3 gram or trigram, right? So basically you have to calculate, or you have to find out the probability of this, মানে what will be the next word, you have to predict, মানে তোমার একটা সেন্টেন্স, there is a sentence up to certain point you heard clearly, but after that you did not hear clearly, so you have to predict what could be the next word. Okay, so for that you can use the n-gram model. Okay, so how to use the n-gram model, that I will show you here with an example. Okay, now suppose there is a corpus like this. Okay, corpus means it's like a database. Okay, so that is your database, that is your corpus, and from that corpus you have to calculate. The question is this, that what is the probability of house such that this is the, so what does it mean? It means that what is the probability that house will be the next word after the word the. Okay, so can anyone tell me what is the probability of this probability? So depending on this corpus, so you have a corpus as an input. From this corpus you have to find out the probability of this one. So can anyone tell me? Okay, so Aditi says 1/4. Is anyone having any other answer? Neha says 2/5. Okay, any other answer? Okay, so now let's see. This is that is the history. Okay, if you compare this thing of this with this example, probability of W such that H, to compute the probability of a word W given some history H. So this is the history, right? So this is the history, and you have to find out the probability of house. So house will be the next word. What is the probability of that? Okay, so first of all, what you need to do? Actually, you need to you need to find out that how many times in this corpus, how many times this part occurs. This is the, right? So how many times this part, this is the occurs? Let's see. 1, this is the 2, this is the 3, this is the 4, this is the, and no other. So 4 times this is the occurs. Okay, and out of these 4, only 1 time the next word is house. Here the next word is malt. Here the next word is rat. Here the next word is cat. Okay, so only one, the house is the next word of this is the. Okay, so what will be the probability? So the probability will be 1/4. So how? So count of this is the house divided by count of this is the, right? Now this is an example of a 4-gram model. Why it is a 4-gram model? Try to understand very, very clearly. Why it is called 4-gram? Here n is equal to 4. Why? The reason is, here you are trying to find out the word sequence of 4. Okay, see here, 1, 2, 3, 4. Okay, so 1, 2, 3, 4. So that's why it is the example of a 4-gram model. Now I am showing you an example of the 2-gram model. Why it is 2 gram? So here my question is probability of Jack such that, right? So my thing is, so I have to calculate the count of that Jack divided by count of that. Okay, here it is written 4/10. So let's see whether actually 4/10 or not. So that, so how many times that occurs? Clearly see. That occur once, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? So 10 times that occurs in your corpus. Now out of this 10, how many times Jack is there after that? 1, 2, 3, and 4, right? So 4/10. So the probability will be 4/10. And that is an example of 2 grams. It is okay?
এটা ঠিক বুঝলাম না, মানে জ্যাকের দ্যাট জ্যাক আর বাই দ্যাট, এটা 4/10 কি করে হলো?
সেটা তো দেখালাম যে তোমাকে দেখতে হবে যে হাউ মেনি টাইমস দ্যাট অকার্স ইন ইওর কর্পাস। এবার আউট অফ দ্যাট হাউ মেনি টাইমস জ্যাক ইজ দেয়ার আফটার দ্যাট। ওকে, তাহলে দ্যাট এখানে দেখো টোটাল 10 টাইমস অকার করেছে। 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Total 10 times the word that occurs. এবারে out of this 10, Jack, how many times Jack is there after that? 1, 2, 3, 4. 4 times Jack was there after that. So that's why probability is 4/10.
স্যার বলছি ধরুন যে দ্যাটটা একটা সেন্টেন্সে 3 বার আছে, তাহলে সেই 3 বারই কাউন্ট করব?
হ্যাঁ অবভিয়াসলি। না, জ্যাকটা শুধু জ্যাক থাকলে হবে না, মানে জ্যাকটা দ্যাটে আছে,
জ্যাক মানে থাকতে হবে।
হ্যাঁ হ্যাঁ, তাহলে।
আর আরেকটা জিনিস স্যার আমি বলছিলাম যে দ্যাট কথাটা যদি একটা সেন্টেন্সে যতবার থাকবে,
হ্যাঁ 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 হ্যাঁ, দ্যাট ইজ দ্য কাউন্ট অফ দ্য ওয়ার্ড দ্যাট ইন দ্য কর্পাস, যতবারই থাকুক না কেন। ওকে ওকে, so now, so here I'm just considered about the single word, right? But that the same principle can be used for compute the probability of a sentence. Suppose I want to find out the probability of this sentence, probability of its water is so transparent, right? It's a sentence, but after I make the tokenization, I got these tokens like this. Its water is so transparent. Okay, now how to do this? Its water is so transparent, right? We know how to calculate the joint probability, right? We have seen this thing when we are discussed about the Bayes network, Bayes rule, etc., etc. So my way out is probability of its dot probability of water such that its মানে কি probability of water where water comes after its, right? Then probability of is such that its water multiplied with probability of so such that its water is multiplied with probability of transparent such that its water is so. Now see what happens. If a sentence is too large, is a too long sentence, then your history will be go very large, right? But gradually your history, the length of the history is very large, right? So maybe in some cases it becomes difficult to calculate. So that's why normally we always try to use the bigram model. Bigram model means what? Bigram model is that the probability of a word depends only on its immediate last word, right? Like this one, the probability of water such that it's, okay? So that is the bigram model. Okay, so here what I am saying that if the suppose transparent, there is a word that after that, and I want to find out that what is the probability of the word the when the history is this. Okay, so if this is an n-gram model, that n-gram model is now mapped to a 2-gram model, that the word, the occurrence depends only on its last word. That means that we have to find out the probability of the such that that means the last word is that. If that is happened, then how many times the occurs after that. Okay, so that's why bigram model is always very much easier to use, but it may happen that sometimes only bigram model is not suitable, so you have to extend it with a trigram model or maybe 4-gram model, right?
মানে স্যার বাইগ্রাম মডেলটা যেটা বলছেন যে ইমিডিয়েট প্রিডিসেসরের উপর ডিপেন্ড করবে,
রাইট ইমিডিয়েট প্রিডিসেসরের উপর ডিপেন্ড করবে। মানে যেমন এটা, যেমন প্রিভিয়াস ওয়ান, the jack that. Okay, so I just want to know that whether jack is occurred after the word that or not. Okay, fine. So that is the idea of the language models, right? What the language model will do. So language model is assigning, so its role is just to assign the probability for every possible words and take the most likely word, the probable word, as the next word. Okay, now so the next thing is, next segment is vector semantics. Now why vector semantics is required? Suppose now if I go back to tokenization again, so you say after tokenizing the string or text, you got these words, right? But how to use those words, how to process those words, right? That is the main job. How to represent those words, because if you work with a machine learning, maybe artificial neural network, you could represent, if these are your inputs, then these inputs should be represented in a numerical form, right? Because how to, and another thing is that you need to know that whether the two words are similar in nature or not, right? So to find the similarity, you have to do some mathematical calculation, some numerical calculation, maybe the cosine rule you can apply, maybe the Euclidean distance you could apply. But to apply all those things, you should have a numerical representation of those words. Okay, so that's why the next segment actually comes into play, the vector semantics. Okay, so vector semantics initiates the representations of the meaning of words called embeddings. Okay, so basically, although I am not going to discuss this thing in today's class. I will keep it for the next class, but still I give you the idea that why the vector semantics is required. Vector semantics actually it represents the words in terms of a vector. Okay, so text is going to be represented as a vector. Okay, so why it is so? Suppose here I am giving you an example of a dictionary where the word mouse is written. Now mouse, it can have a different meaning, right? Any of numerous small rodents, that is a one meaning. A hand operated device that controls a cursor, that is another meaning. Okay, so that is called a word sense. That is called a word sense, right? So there can be a variety of senses of a particular word, right? That I have already mentioned, that whenever you are saying or whenever you are listening somebody, then you have to find out that in which sense, in which context he is saying that thing. Okay, and similar, another thing is that maybe two words can be similar in nature. Okay, say couch or sofa. You use a word couch in somewhere, you have used the sofa in another word, another place. So these two are similar in nature, right? So you have to understand that whether two words are identical or similar or not. So for that you should have a suitable representation of those words. And that's why the vector semantics comes into play. So it defines the meaning of a word W as a vector, a list of numbers. Okay, each version defines the numbers in the vector somewhat differently, but in each case the numbers are based in some way as counts of neighboring words. And one of the representation, I will continue from this part in the next class, that is a bag of words. Right, bag of words means you can get the idea from the term itself, bag of words. So there is a bag. In that bag, a lot of words are there. Okay, but it's an unordered set of words. Okay, only the count is mattered. Okay, like say here it is written the counts of every word. Say eat occurs 6 times, I occurs 5 times, the occurs 4 times, to occurs 3 times. Okay, in this way. So these are called a bag of words. Right. So how to represent that word as a vector, that is an important thing to know. Clear? Is it okay?
Okay, sir.
Okay. So I will stop over here in today's class, and I will continue in the next class from this point. Okay, so anyone having any question up to this, whatever is discussed today, you can tell me.